Hi guys, welcome to God Academy, and in this lesson I'll be taking you through equations of a plane. So this is another lesson under vector algebra, and if you have missed all the previous lesson, which is equations of a line, you've done the triple dot product, scalar dot product, and all the others. Please subscribe and don't forget to share whatever you've learned to others. So when we talk about equations of a plane, what do you mean? First of all, what is a plane actually? So if you have a line, is so simple to define a line by a direction that is pointing here, is pointing that. What if you have a plane like this? You have a plane like this. How do you define the direction of this plane? It's so difficult. To define the direction of a plane, we use a vector which is perpendicular to the plane to define it perfectly. So if I introduce a vector which is perpendicular, then I will say that this vector is pointing down. Is that not it? Yeah, I will say that the vector is pointing this way or that way. So we use what we call a normal vector to always define the direction of a plane. So how do we get a normal vector? It's finding any vector which is perpendicular to all the other points within the plane. Then let's go straight finding the equation of a plane. Okay, if I have a plane here, right, I have a random point P right here, and I have a random point, or let's say a known point Q, right? And as I'm saying, let's say PR, there are points on this plane. We have this, which is our normal vector, right? Defining the whole direction of this entire plane. Now I need to know the equation of this plane. I need to know the equation of this plane, right? So mostly we use to find the equation of this plane. Remember that this vector that we have here, right? The normal vector is perpendicular to any vector within this what plane. Is one thing you should know. And from dot product, you know that any two vectors which are perpendicular is said to give us what? Zero. That's not it. Therefore, to find my equations of a plane, therefore to find the equations of a plane, we simply say that my normal vector dot any random vector is giving me 0. I'm using R and R naught to symbolize just finding the vector, right, in space, where R naught is what you know, R is what you don't know, right? Taking any 2 points, a known point and an unknown point, if I subtract, remember, I'm going to get the vector, and I'm going to find the dot product with my normal vector, and that should give me 0 for that to be perpendicular. So equation of a plane stems from this equation. Then now, normal vector is simply a direction vector. It also have the normal thing. So this one I can say that nr minus nr naught is equal to 0, right? My nr will be equal to my nr naught, right? This is a very nice equation that I've given to you. Okay. So here we are still not done, right? Remember that we can say, so at this point, let me just hit from here, right? So I will say that if I have my directional vector, so my n is my normal vector a, b, then c, right? As this dots my r, which I don't know, my arbitrary a number, and z, which is being subtracted by my r naught, x naught, y naught, then z naught, and we are saying that it should be equal to 0. So here what do we get? We end up getting a x minus x naught plus b y minus y naught plus c z minus z naught is equal to 0. So this is actually the equation of a plane. Standard equation of a plane. Have in mind your a times x minus x naught, where your a is just your direction vector which will be given to you, or your normal vector which may not be given, but you have to find the normal vector yourself. Then the x is what you don't know, any arbitrary. Then x naught is the known point. As simple as that. It's the same as you finding the equation of a line where you need your direction. Now our direction is a vector instead of a number. Then we have arbitrary x, which we can find for every point in space, then x naught as our what? As our known point. As simple as that. Okay, let's solve a problem here and see. It says that find the equations of the plane through the points 2, 4, -1 with normal vector. Okay, through the point, so it's not a vector. Through the point 2, 4, -1 with normal vector, n is equal to 2, 3, 4. You have to find the equation of the plane, right? Which passes through the point this and the normal vector. So here, life is so easy. We've been given a normal vector, we have a point. It's so simple. What do? You take your 2, okay? 2 multiplying x, which you don't know, but let's do it systematically to make it beautiful. So here, you have your formula quoted. What's your formula? N times r minus r naught. N dot r minus r naught is equal to 0. What is my n? 2, 3, 4 dots. R, which is was x, y, then z, right? Minus my r naught, which is always a point, which is x naught, y naught, then z naught. All this here is equal to 0. So I have 2 times x minus, no, let me still solve it systematically. So I have this, so 2, 3, 4 dots. I'll have here to be equal to x minus x naught, y minus y naught, z minus c naught for this equals 0. So 2 times x minus x naught plus 3 times y minus y naught plus 4 times z minus c naught is equal to 0. What do? Multiply through, right? But before then, we know that our x naught is given as 2, 4, -1. So my x naught is 2, x minus 2 plus 3, my y naught is 4, y minus 4 plus 4. I have z minus 1, so plus 1 for 0. So I'll have this to be 2x minus 4 plus 3y minus 12 plus 8. Oh no, plus 4z minus. So our equation was -1. So 4z minus. So to be minus, so plus. So plus 4. So 2x plus 3y plus 4z. Then -4 minus 12, minus 4, 20. Minus 20 equals 0. So this is our equation of a plane. Beautifully done. As simple as that. Simple as that. I have one beautiful says that find the equation of a plane that passes through the point P 1, 3, 2, Q 3, -16, R 5, 2, 0. We have to find the equation that passes through a plane which is having all these points within the plane. As I said, the first thing to do is to find the vectors. Okay, we need a normal vector. And after finding the normal vector, we can use any of these points to find our equation. To find a normal vector, I need to find the cross product of any two vectors here, PQ and PR, right? It's so important to find the vector, which is, so let's draw the plane here. I have point P, point Q, point R. So PQ is a vector, PR is a vector. To find the normal to this plane, it should be perpendicular to any of them as this. So, and that's exactly the cross product of PQ and PR. Let's find PQ. PQ is OQ minus OP, right? And this is equal to, what's my OQ? I have 3 -16 minus what? 1, 3, 2. Is that not it? 3 minus 1 is giving me 2. 3 minus 3 is giving me -4. 6 minus 2 is giving me 4. I'll have my PR to be OR minus OP. Is that not it? My OR is simply what? 5, 2, 0 minus my OP is 1, 3, 2. This gives me 5 minus 1 is 4, 2 minus 3 is -1, 0 minus 2 is -2. At this point, I'll find my cross product, and it's simply ijk. First one becomes your second row, 2 neg 4 4, then the last one 4 neg 1 neg 2. Then you find your determinant, as simple as that. So I'll have my vector I plus minus plus. It will cancel. I'll have -4 times -2 minus -1 times what? 4. So this gives me what? That's I, right? Minus j multiplying, this will nullify. 2 multiplying -2 minus 4 times 4 plus k multiplying everything here will go. I'll have 2 times -1 minus 4 times -4. Nicely. At this point, let's see. This gives me -4 times -2 is what? +8 minus -4. That is +12i. So I have negative j here. I have 2 times -2 is -4 minus 16. That is -20, but with +20 what? J. Then when I come here, 2 times -1 is -2. Minus 4 is minus, so it will be +16 minus 2, which is 14. Okay, that's simple. So I have 12i plus 20j plus 14k as my direction vector. Then let me choose any point, let's say P, which is given as what? 1, 3, 2 to find the equation. So my equation, now at this point, I know you can see it clearly. I take my direction number A, which is 12, open brackets, x minus 1. I take my direction number B, 20, open bracket, y minus 3. I take my direction number C, 14, open bracket, z minus 2 equals 0. As simple. I have 12x minus 12 plus 20y minus 60 plus 14z minus 28 is equal to 0. So 12x plus 20y plus 14z, -12 minus 72 minus 100, right? Yeah, equals 0. So this is at this point you can cancel through, right? 6x plus 10y plus 7c minus 50 equals 0. We can cancel. Let's hold it on this. So this is beautifully what we have gotten as equation of a plane. Thank you for being with me in this video. See you in our tutorials. Please don't forget to subscribe and share.